Morning everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is a database design concept, and the same chapter, that is a chapter number, sorry, the new chapter, that is a new chapter, that is where part number 5, that is a case studies. In the last class we have finished with various parts, that is a part number 6, part number 4, that is we have studied, that we have finished in the last class. Now I'm going to start with the new part, that is a part number 9, that is a case study. This is somewhat related to the scenario based questions or scenario based option that is used for the case studies, that is used in the various database, that is used in the database design concept. So we have finished with the chapter number 26. So let's recall what we have covered in the last class, then move to the today's topic, that is part number 5, or sorry, part number 9, case studies. So in the last class we have started with main memory database, that is chapter number 26, that is a part of chapter number 26, that is the main memory databases. So what is the main memory databases? So any database that is maintained for the main memory, that is maintained for the internal memory, that is the main memory databases. So to allow a high rate of transaction processing, we must use the high performance hardware and must exploit the parallelism. And these techniques are insufficient to obtain very low response time. Since this input output remains a bottleneck, that is about 10 million seconds are required for each input output operations. And this input output is often the bottleneck for the reads as well as for the transaction commit. So whenever there will be a transaction commit, that will be used for the reading operation, that will be used for the writing operation as well as for the transaction commit. The long disk latency increases not only the time to access a data item but also limit the number of accesses per second. So it also limit how many accesses are available per second, or how we can able to access the per second time. That is also a part of the main memory database. And we can also maintain the database with the less bound that increase the speed of the or size of the database buffer at a minimum speed at a minimum size. And for most of the application, or for many applications such as the real-time control, it is necessary to store data in the main memory to meet the performance requirement. That is, it is necessary to meet the requirement or store the data in the main memory, so that memory or data will be stored in the main memory to meet the performance requirement. That is how much performance is required, that is the performance requirement. The memory size required for most of the system is not exceptionally large, although there are at least a few applications that require much gigabytes of data to be memory resident. And since these data are very fast speeds, increasing number of applications can be expected to have data that fit into the main memory. And large memory is also used for the processing of the database, but there are some limitations of the large scale memory that we have discussed in the last class. So these are the various limitations of the main memory concept that we have covered. That is, these are the limitations. One of the limitation is the log records must be written into the stable storage before a transaction is committed. So log record must be written into the stable storage, into the stable place where the commit or the when the commit or before the transaction is to be committed. And the improved performance made possible by making or by a large memory main memory that may result in the logging process becoming a bottleneck. So these are the various types, these are the various, we can say, the terms that is used when a transaction is committed. The improved performance made possible by a large main memory may result in the logging process becoming a bottleneck. And we can reduce the commit time by creating a stable logs buffer in main memory using non-volatile RAM, that is implementing using the battery backup memory. And the overhead imposed by logging in can be reduced by the group commit technique that is used. Another drawback that is used is the buffer block that is marked as a modified by the committed transaction still have to be written, so that the amount of log that has to be replayed at recovery time is reduced. So recovery time is reduced, so that we want to maintain the buffer block that is marked as a modified by committed transactions. And if the system crashes, all of the main memory is lost. On recovery, the system has an empty database buffer and data item that must be input from the disk when they are accessed. So whenever they are accessed, they are uses the system crashes, or in case system crashes, all of the memory is lost. So when the memory is there is no use of the database, we can say the database occurrence or database maintenance. So whenever there will be a recovery, the system has an empty database buffer and data items that must be input from the disk when they are accessed. Therefore, even after the recovery is complete, it takes some time before the database is fully loaded in the main memory and the high-speed processing and this year. On the other hand, there are some opportunities, or we can say there are some advantages also of the main memory database that is used. One of the opportunity that is used, since memory is costlier than the disk space, so internal data structure in main memory database have to be designed to reduce the space requirement. So the requirement is very high, so the internal data storage in the memory requirement has been designed to reduce the space requirement. And there is no need to pin the page buffer or the buffer pages in the memory before the data is saved. Then query processing techniques should be designed to minimize space overhead so that the main memory limits are not exceeded while a query is being evaluated. Then once the disk input-output bottleneck is removed, operations such as the locking and the lashing may become bottleneck. And so these are the various opportunities so that the disk input-output can be maintained with the help of the bottleneck, or these are the various, we can see the scopes that is available for the input-output of the main memory databases. The next is recovery algorithm that can be optimized since pages rarely need to be written out to make spaces for the other pages. That is a recovery algorithm that can be minimized or that can be optimized, that are used since the pages, or that can be optimized means that can be reduce the cost so that the pages rarely need to be written out to make the space for the other pages. And the process of committing a transaction T requires these records to be written to the stable storage. So first of all the log record that is associated with the transaction T must be written to stable storage. Then the T commit protocol is ruled out, or we can say the login again, that is a T commit protocol. And these output operations frequently require the output of the blocks that are only partially filled. And to ensure that the full blocks are output, we use the group partial or group commit technique that is used. So instead of attempting to the commit T, and when T commits or completes, the system wait until the several transactions have completed. And RAM is also a type of the volatile or the non-volatile memory that is used for the various buffering. The next we have discussed is the real-time transaction system, in which the time plays an important role. That is a real-time transaction system in which the deadline is very constrained, or the constraint is available that includes a deadline by which a task must be completed. The integrity constraint that we have considered thus so far pertaining to the value that is stored in the database. So that is the integrity constraint that is available, that is used for the deadlines. In certain applications, the constraints include the deadlines by which a task must be completed. That means a deadline is given, that is a constraint deadline that is used in which uh, that is a constraint within the limit by which the deadlines is used by which the task must be completed. That is, the deadline means a deadline or date or dead date in which or by which the task has to be or must be completed. Example includes plant management, traffic control management, and the scheduling. So these are the various real-time transaction system example that is used. Rather, we are concerned with how many deadlines are missed and by how much time they are missed. And there are multiple types of deadline that we also discussed, that is the hard deadline, firm deadline, and the soft deadline. And system with deadline, that is system with the, we can say, the deadline scenarios that are time based, that is known as, or that are known as the real time systems. And the transaction management in real time system must contain the deadlines in according to with the count in the accountant. But the major difficulty in supporting the real-time constraint arises from the variation in the transaction execution time. So execution time for each transaction is different. That is one of the major limitation, because suppose the deadline is given and the transaction may not commit till the deadline. So that transaction, that application may fail due to the time bound. This is the one of the limitation that is used for the deadline limitation, that is used for the deadline capacity. And in the worst case, each access causes a buffer page to return to the disk, that is followed by the reading from the disk of the storage. That is also one of the, we can say access technique that is used. And because the two or more disk access required, the worst case scenario that is used. So the worst case scenario that takes the several order of the magnitude, that is more time than the main memory references that is required in the best case. Hence, the main memory databases are often used if the real-time constraints have to be met. So, they are more used, or main memory databases are more often used or more frequently used if the real-time constraints have to be met. Next is the long duration transactions. That is a transaction that is used for the long duration. That is, we can say that is used for the long time. That is a long duration transaction that is used. That is the data processing applications in which the most transactions are interactive or non-interactive and is of the short duration. And the technique that is used, that is applied to the database system, that involves a human interaction. And such transaction have a key property that is used. So a long duration transaction have the properties like the long duration that is used. So once a human being is with an active interaction that is used, the transaction becomes a long duration transaction from the perspective of the computer. That is a long duration. Then exposure of the uncommitted data. Then subtask that is used. So one is a long duration, one is the exposure of the uncommitted data, one is a subtask, then recoverability, then performance. The next is a non-serializable execution that will be used. So that means that is available in a non-serialized way. That is a non-serializable execution that must be placed whenever there will be data, whenever there will be requirement of the data. That is a non-serializable. That means there is no serial way. The data is available in the non-serialized way, and there are multiple protocols, or we can say the transaction that is used. One is the two-phase commit protocol, two-phase locking protocol. One is the graph-based protocol that has to be used while preventing for the deadlock. Then the timestamp protocol that requires a transaction to wait for the another moment or for another transactions. Then validation protocol, like a timestamp protocol, the validation protocol enforces reliability by means of the transaction abort. So if I want to enforce the serializability that results in the long duration waits in abort of the long transaction or long duration transaction or in both. And the next is a concurrency control. That is a fundamental goal, or that is a fundamental aim of the database concurrency control is to ensure concurrency execution of the transaction does not result in a loss of the database concurrency. So whenever we use or whenever we execute the database that is used, that is we are ensuring that concurrency or concurrent execution of the transaction might not result in a loss of the database consistency. So if we are executing the more than one transaction at the same time, there will be no loss of the database consistency. And the concept of serializability can be used to achieve this goal, since all serializable schedule preserve the consistency of the database, and not all schedule that preserve the consistency of the database are the serializable. And it also illustrates two important points about the concept of the correctness without any serializability. The first is correctness depends on the specific consistency constraint for the database. So whenever we use the correctness word, that depends on the specific consistency that is the constraint for the database. Then second point is correctness also depends on the properties of the operation that is performed by each transaction. So whenever there will be a transaction that will be used that is performed by the transaction that is related or that is specific to the consistency constraint for the database. This is the example of the non-conflict serializability control that will be used, that is used for the database connectivity, or that is used for the database consistency or concurrency issue problem. Then nested and the multi-level transaction that is used, so there will be a nested transaction also, that is the one after the another, and there will be a multi-level transaction that is one level within the another level, that is a multi-level transactions. Then compensating the transactions, that is the next part, that is how to deal with the problems. Then implementation issues, that is what are the various implementation issues while implementing the concurrency controls. There are multiple difficulties that is used, like what are the two approaches that is used to reduce the overhead. One is the operation logging, that is the operation logging will be used, and the logging and the shadow paging. So these are the two techniques by which the overhead will be decreased. One is the operation logging, one is the logging and the shadow paging. So these are the two methods by which the techniques by which the logging or by which the overhead of ensuring the recoverability of the larger data items. Now next is a summary of this chapter. First says workflows are activities that involve the coordinated execution of the multiple tasks that is performed by the different processing entities. The next is, although the usual ACID transactional requirements are too strong, that is atomicity, consistency, isolation, and the durability are too strong and are unimplementable for such workflow applications. Workflow must satisfy a limited set of transactional properties that guarantee that a process is not left in an uncertain or inconsistent state. Then transaction processing monitors were initially developed as multi-threaded servers that could service large number of terminals from a single process. Then e-commerce system have become core part of the commerce that is used, that is the e-commerce system, and there are multiple or there are several database issues that is used in the e-commerce system that is used. For example, the catalog management, that is the personalization of the catalog, that is also done with the databases. Then next part is large memory database or large main memory database that is also used for to achieve the high system throughput that is used. In this, the logging is a bottleneck, and the system or the group commit concept is used, that is a used to use the stable storage that can be reduced, therefore reducing the bottleneck. The next is the efficient management of long duration interactive transaction is more complex because of the long duration waits and because of the possibility of abort. Then the next is long duration transaction is represented as a nested transaction with atomic database operations at the low level. So whenever we use the long duration transaction, that is represented as a nested transaction that is used with the atomic database operations at the lowest level, that is used at the lowest level what are the various atomic transactions that is available. Then in systems with the real-time constraint, the correctness of the execution involves not only the database consistency but also the deadline satisfaction. That is a real-time constraint, that is the correctness of the execution that involves not only the database consistency but also the deadline satisfaction. Now comes to the next part, that is a part number 9, that is the case studies. And this part describes how different database systems integrate the various concept that is described earlier in this book that is used. And there are multiple chapters in this, that is chapter number 28, 29, 39, 30. Then these three chapters represents how much is widely expected of the commercial database system that includes the SQL, variation, extension that is used for the storage optimization, organization, query processing, concurrency control, recovery, and the applications. The chapter covers not only key aspects of database of product they describe, and therefore they should not be regarded as a comprehensive coverage of the product. Furthermore, since products are enhanced regularly, details of the product may be changed or may change. And when using a particular product version, be sure to consult the user manual for the specific details. So keep in mind that the chapter that is part often use the industrial rather than the academic terminology that is used of the relation, tuple, and the column instead of the attribute. Now chapter number 7, that is a PostgreSQL. So it is an open source object relational database management system. So PostgreSQL is an open source object relational database management system that is used with the open, or that is the open base or open source. That means open source means that is common to, or that is available to each and everyone. There is no foundation to access the database management system, that is the object relational database management system. It is a descendant of one of the earliest such system, the Postgres system developed under the professor Michael Stonebreaker at the University of California, that is in Berkeley. The name Postgres is derived from the name of a pioneer relational database system, that is the Ingers, that were also developed under the Stonebreaker at the Berkeley. There will be a C, C++, Java that will be used for the database interfaces. And what are the various interfaces? Like the JDBC, that is a Java database connectivity, and the ODBC, that is the open database connectivity that is used for the connection with the database, as well as the we can say the programming and any language that is used for the programming. So introduction of this, that is the Postgres, that is gone that is undergone various several major releases that is used, that is the PostgreSQL. The first version that was distributed to the users in 1989 that provide the features such as extensible data types, preliminary rule system, and a query language that is known as the PostgreSQL. And the PostgreSQL runs under virtually all Unix-like operating systems, including the Linux and the Apple Macintosh operating system. And today, PostgreSQL is used to implement several different research and the production applications. So whatever the research application, whatever the we can say the production application that will be used, that is available or that is used to implement with the help of the PostgreSQL, and an educational tool at the several universities. The system continued to evolve through the contribution of the community of about 100 developers that is used to develop the thing, that is used to make the we can say the contribution of each other of each part of the transactions. In this chapter we explain how PostgreSQL works, starting from the user interfaces and languages and continuing into the heart of the system. Now, next part is the user interface. So the standard distribution of the PostgreSQL comes with a command line tool. So, what is the interface of the PostgreSQL? That is a black screen. That is a CUI. That is a character user interface. And there is a wide range of commercial and open source graphical admin that is also used that supports the PostgreSQL. And this the first part is the interactive terminal interfaces that is used for the database administrator, and there are multiple variables or multiple features that is used. So one is a variable that provides the substitution feature that is similar to the common Unix command shells. So whatever the command shell that we are given in the Unix operating system, the same commands will be available in this one, that is a database that is very similar to commands. Next is the SQL interpolation. The user can substitute or interpolate PLSQL or PSQL variable into the regular SQL statement that is used by placing the colon. So whenever we use them, so we can use the PLSQL by using the colon that is used. Then the command line editing that is used that uses the GNU, that uses the GNU environment or read line, that is library for the convenient line editing with the table or tab completion support. And then next is the graphical interfaces that is used. This is the graphical interface of the PostgreSQL. That is the PC admin 3, that is open source GUI. Then the programming language interfaces that is used. There are multiple interfaces of the programming language, that is the ODBC and the JDBC. This is one of the example of the JDBC and the ODBC. Then the next is the SQL variants and the expressions or the extensions. So the current version of the PostgreSQL supports almost all entries level, that is SQL 92 features, as well as many of the intermediate and the full level features. It also supports the many SQL 1999 and the SQL 2003 features. So there are two types of features that is also available. One is the SQL 1999, one is the SQL 2003 features. That includes most object relational feature that is described in chapter number 22, and the SQL XML feature that is used for the parse XML data. Next is the PostgreSQL types that is used. There are multiple types of PostgreSQL types. Then these are the various systems that is divided into various categories. One is the base types, that is also known as abstract data type, that is the modules that can encapsulate both the state and the set of the operation, that is the base types. Then composite types, that is the next part that is used, these correspond to the table rows, that is they are a list of the field name and the respective type that is used, that is the composite types. This is the example of this one, that is a product summary, quantity, place, username. Then next is a domain, that is under which domain, that is defined by coupling a base time with the constraint the value has taken. So whatever the value has taken, whatever the domain, whatever the base type that is used with the constraint that the value of the type must satisfy. And the values of the domain type and the associated base type may be used interchangeably, provided that the constraint is available or constraint is satisfied. The next is the enumerated type that is used, that is the enum is also used, that is used in the programming languages such as the C and the Java, that is the enum type, that is the enumerated type. Then next is the pseudo types that is used. So Postgres also support the following pseudo types, that is any array, any element, that is any num, any known array, string, internal, opaque, record, trickle, and the void. The next is the polymorphic type that is also used, that is anonymous and the array-wise. The non-standard type, these are the non-standard type that is used. Then rules and other active database feature that is used, that is used with the constraint triggers that is available for the query rewriting or rewriting rule that can be declared on the server. And Postgres or the Postgres SQL also allow the check constraints, not null constraint, and the primary key and the foreign constraint with restricting and cascading the deletes. Like many other relational database systems, Postgres protocol or Postgres SQL support the triggers, which are useful for non-retrievable constraint and consistency checking for the enforcement of the user. And the Postgres SQL rule system allows the users to define the query rewrite rules on the database server. That is the Postgres SQL that is used to define the query rewrite rule that is available on the database server. This is a syntax of the rule that is used. This is we have already discussed, that is how to create the rule, that is a create rule and the rule name. Then next is the extensibility, that is how to extend the content, how to extend with the help of the Postgres SQL. So like most SQL or most relational database system that is used, the Postgres stores information about the database, tables, columns, and so forth, in which or in what are commonly known as the system catalogs, which appears to the user as a normal tables. Other relational database systems are typically extended by changing hard-coded procedure in the source code by loading the special extension module that is written by the vendor. The next is the types of the Postgres SQL that is used. So the Postgres SQL allows the users to define composite types, enumeration types, and even new base types. That allows the user to define the composite types. Then the composite type definition is similar on the table definition that is used, that is a standalone composite type that are typically used for function argument. For example, the definition that is used, that is the create type ctt as name varchar 80 state char 2, that allows the function to accept and return ctt tuples even if there is no table that explicitly contains rows of this type. And the enumeration, that types are easy to define. So why it is easy to define? Because the symbols or the numbers are assigned to the characters or the words, so everything is available with the help of the number. So that's why enum is very easy to define by simply listing the names of the value. This is status t as a enum, alpha, beta, and the release. So alpha contains the 0 value, beta contains the 1 value, and the release contains the 2 values. So this is 0, 1, and 2. And the next step is to define the function to read and the write values of the new type in the text format. The next is the function, that is what are the various functions that is used in the Postgres SQL. So the Postgres SQL allows the user to define the function that are stored and executed on the server. So it is used to define the function that is executed on the server that is used. And the Postgres SQL also supports the function overloading, and that is a plain text or the plain SQL statement that is used with the procedural languages that is used. And finally, the Postgres SQL has an application programmer interface for adding the function that is written in the C, that is the Postgres SQL. User-defined functions can be written in the C or a language with compatible calling conventions such as the C++. The actual coding conventions are essentially the same for the dynamically loaded user-defined function as well as for the internal functions. The next is the index extension that is used as a B-tree high indices or the hash indices, and adding the index extension for a type that requires the definition of an operator class, which includes the encapsulation for the following. The next is the procedure languages that is used. So what are the various procedural languages that is used? So that includes the procedure or that is used for the various we can say the programming, that is the procedural languages. So one of the or some of the procedural languages are as follows, that is a PL, that is a PG SQL, then PL, TCL, PL, PAR, PL, Python. So these are the various languages that are the various privileges that is used as procedural languages. The next is the server programming interface that is used, that is the SPI, that is an application programming interface that allows the user-defined C function. So whatever the C function that is used, that allows the user-defined C function, that is application programmer interface, that is the SPI, that is server programming interface. The next is that transaction management in the PostgreSQL. So how to manage the transaction, that is the transaction management. So transaction management in PostgreSQL uses both snapshot isolation and the two-phase locking protocol. That is the transaction management that is available in the SQL, that is available in the PostgreSQL. And for more DML statement, the snapshot isolation is presented in figure 5 or section 15.7, that is we have already used. That is the how to maintain the snapshot isolation technique that is used to maintain the snapshot technique, that is available with the MVCC, and that is the one of the PostgreSQL or the PostgreSQL that is used. And the concurrency control for the DDL statement on the other hand is based on the standard two-phase commit protocol. This is the Postgres concurrency control, PostgreSQL isolation levels that is used. Next, PostgreSQL implementation of the MVCC that is also used for the database administrator. And these are the various operations that is used with this one, that is the insert, select, update and the delete statement. So these are the various statements that is used with the PostgreSQL. One is the insert statement, select statement, update statement or the delete statement. And the update or the delete statement can proceed and perform the actual modification that is used. And the update information is used for the updating the content, that is a various ways to update the content, and there will be a delete operation also to delete the value, delete the transactions. The next is the implications of using the MVCC, that is what are the various implications that is used with the MVCC. So using the PostgreSQL, MVCC scheme has implications in three different areas. One, extra burden is placed on the storage system since it needs to maintain the different versions of the tuples. Second, developing the concurrent application takes some extra care since the PostgreSQL MVCC can lead to the subtle but important differences in how concurrent transactions behave compared to the system that is used or where the standard two-phase locking is used. Then the PostgreSQL, that also performance or that performance depends on the characteristics of the workflow or the workload that loading in or that is running on it. Then the DDL concurrency control, that is the data definition language concurrency control, that is used as the concurrency control in which the MVCC or the index will be maintained that will execute the concurrent transactions. Then the locking and the indices. So all current type of indices in PostgreSQL allows for the concurrent execution or access by multiple transactions. This is typically enabled by page level logs so that different transactions may access the index in the parallel if they do not request conflicting logs on a page. So that is the locking and the indices. The next is the recovery. So historically, in a history basis, PostgreSQL did not use the write height logging, that is the WAL for the recovery, and therefore was not able to guarantee consistency that is available in system of a crash. Next is the storage and the indexing, that is how to store the data that is stored in the table spaces. This is one of the example, that is how the data will be stored in the table. Then first is the table. The primary unit of our storage is a table. So the primary method or the primary mode of the storing the data in the PostgreSQL is the table, and the table are stored in a heap files, and these files use the form of the standard slotted page format that is described in section 10.5, and the PostgreSQL format is available in this figure, and each of the page a header is followed by an array of the line pointers, and the line pointer hold the offset that is used and the length of a specific tuple in the page. There will be a tuple ID that is used, and the indices, that is a data structure that provides a dynamic mapping of the such predicate to the sequent tuple that is used. Now, what are the various index types that is supported by the PostgreSQL? So the PostgreSQL is supported the three indices and the following type of indices, that is the B tree, then the hash, then the gist, then gin, that is the generalized invented or inverted index. And these are the few other index variation that will be used that supports more complex variations. One is a multi-column indices, one is a unique indices, then indices on the expressions, then operator classes, partial classes that is used. Then how to create the index? This is the syntax, that is how to create the index, that is create index installment salary index on the instructor salary. Next, query processing and the optimization. This topic we have already discussed, that is how to optimize a query and how to process the query by using various techniques like a system planner, genetic query programmer that is used, that is available with the database resources. Next is the query executor, that is how to execute the query, that is provided by the query executor, and these are the various methods how to execute the query. Now next is the system architecture, that is system architecture of the database or the PostgreSQL. So let's take a break right now, then move to this chapter or this topic, that is system architecture. So let's take a break right now. So come back from the break. Now let's start the session again. Next is the system architecture, that is how to, or what is the architecture of the system, or how to use the system, that is system architecture. So the PostgreSQL architecture follows the process per transaction model that is used or that is managed by the central coordinated process that is known as the postmaster. That is the system architecture that is managed by the central coordinated process. And the postmaster process is responsible for initializing and shutting down the server and also for handling the connection. That is also used for handling the connection, that is used for making the connection, that is used for the building the connection generally, that is used as a general manager, that is used for building the postmaster connection. And the client applications can connect to the PostgreSQL that is used and submit the queries through one of the databases to one of the many databases that is used. That is a database application programmer interfaces that is supported by the PostgreSQL, that is supported by the SQL that is available at the client side libraries. And the example that may includes the PostgreSQL and the command line space SQL that is available, that is used, that is included in the standard SQL output, that is included in the standard SQL connection, that is the initial client connection. For this, it is commonly used, or listen for the new connection that is used, that is available as a port. And after performing the initialization steps such as user authentication, the postmaster will span a new backend process to handle the new client. And this is the PostgreSQL system architecture. There will be a client process, that is a client application, that communication to the library API, then server processes, then initial connection request and the authentication, then the postmaster daemon process, then the shared memory, that is the shared disk buffers, shared table, kernel disk buffers, and the disk storage. So these are the various Postgres or the PostgreSQL system architecture. And the use of shared memory as a communicator medium suggests that the Postgres server should run on a single machine, single side, that will be available in the Postgres sequence determinant. Now next is the bibliographic notes. Next chapter is chapter number 21, that is Oracle. This is one of the, we can say, the practical topic that is used, that is Oracle, that is used. And Oracle is the advanced part of the, we can say, the SQL. So Oracle provides a variety of tools for database design, querying, report generation, and data analysis. That is the Oracle that provides a variety of tools, number of tools that is used for the database design, querying, and the report generation, and the data analysis that includes the OLAP. These tools, along with the various other application development tools, are a part of portfolio of the software product that is known as the Oracle Fusion middleware. And next is the database and application design tool that is used, that is an end-to-end J2EE based server program that is based on the framework that is based on the model view design pattern. In this framework, an application consists of the multiple layers, and the model and the business service layers handle the interaction with the data sources and contains the business logic. That is, the business logics are used for the various database administrator or database admin blocks. The primary development tool for the Oracle ADF is Oracle JD or JDeveloper, which provides an integrated development environment with supports for the Java. So whatever the Java, whatever the Oracle requirement, whatever the ADF that is used, that is available with the Oracle JDeveloper, that includes an integrated development environment that supports for the Java. So there are multiple languages that is supported by the Oracle, that is an integrated development environment that is included with the Java, XML, PHP, HTML, JavaScript, and it has built-in support for UML modeling. That is each of the language that is used that has a built-in support that is used for the UML modeling. And the Oracle Designer is a database design tool which translates the business logic and data flows in the schema definition that is available for the application logic. And Oracle also has an application development tool for the data warehousing that is used, and data warehouse builder, that is a tool for the design and development of all the aspects of the data warehouse, including a schema design, data mapping, and the transformation. Next is the querying tools. So Oracle provides a tool for ad hoc querying, report generation, and the data analysis, including the OLAP. And there will be OBI, that is a comprehensive suite of the tools that sharing the common service oriented architecture that is used, that is the OBI, that is the Oracle Business Intelligence Suite, that is the OBI. And the component for the ad hoc querying, that is Oracle OBI answer, is an interactive tool that presents the user with a logical view of the data that includes the hiding the details of the physical implementation, that is how to or that is hiding the details of the physical implementation that is available in the ODI or OBI. Next, SQL variations and the extensions. So SQL or Oracle supports all the core SQL 2003 feature that is fully or partially either available in the Puri or the fully or the partially, with the exceptions of the feature and conformation or conformance views. In addition, Oracle supports a large number of other language constructs, some of which are available with the Oracle functionality or features of the SQL Foundation 2003, and others are Oracle specific in syntax or the functionality. So it depends on the functionality of the system to system. Next is the object relational feature that is used. So Oracle has an support or extensive support for the object relational feature that is used, that includes the object types, that includes the collection types, object tables, table functions, object views. So these are the object relational features that is used. Then methods, then user defined aggregation or aggregation tools. Next is Oracle XML DB, that is the Oracle XML database or DB, that is a database that provides in-database storage for the XML data and support for a broad set of XML functionality that includes the XML schema and the XQuery. So that includes the XML schema and that includes the XQuery that is used with the database administrator. And some of the high level features of the XML DB include the support for the XQuery language and the process that lets the XML transformation that will be performed inside the database. Next is the procedural language that is used. So Oracle has two main features of procedural language, that is the PLSQL and the Java, that was originally developed for the stored procedural and had a syntax that is similar to the ADA language, that is the procedural languages. And there will be a dimension that is the dimension that is used, that is the dimensional modeling, that is a commonly used design structure for the relational star schema as well as the multinational schema. Then OLAP, that we have already discussed, that is a OLAP is also used as or provides a tool for the analytical database processing, that is the online or we can say the Oracle lab analytical processing. Then triggers, that is a trigger means we can say the scenario or constraint that is available. So Oracle provides several types of triggers and several options for when and how they are invoked, that is the triggers. And triggers can be written in the PLSQL or the Java as the C callouts. For triggers that execute on a DML statement, such as the insert, update, and delete, Oracle support the row triggers and the statement triggers. And Oracle also allows the creation of the instead of the triggers for the views that cannot be subject to the DML operation. That is a use for the creation of the Oracle of the instead of the triggers. Then the storage and the indexing, that is how to store the data, and there are multiple techniques to store the data, that is the storage and the indexing. That means the index will be created, that means with the reference of the index that will be maintained for the index structure, that is the indexing. So one is the storage, one is the indexing that is used. So in the Oracle parallelism, a database consists of the information that is stored in the file and is accessed through an instance, which is a shared memory area and a set of processes that interact with the data in the file. That is a database server that is a collection of the various information that is stored in a file and in accordance with the various instances that is available with the data files. And the control file is a small file that contains high level data that is required to operate in an instance. That is a storage. So one is the table spaces, that is consist of the various logical storage unit that is known as a table spaces, and there will be data files, the file that is used for storing the data that is known as the data files. The system and the auxiliary sys aux table spaces, which are always be created, they contain the data that is used for the various data that is available in the database architecture, and the database admin that will be used, and the data spaces that is created to store the user data. While the user data can be stored in the system table space, it is often desirable to separate the user data from the system data. Then next is the segments, that is dividing the table space into multiple parts, into multiple units, that is known as the data segment. So the space in a table space, or whatever the space that is available in a table space, that is divided into multiple chunks, that is divided into multiple units, that is known as the segments, each of which contains data for a specific data structure. And there are four types of segment that is used. One is a data segment, one is an index segment, one is a temporary segment, one is a undo segment. So these are the four segments that is used in that table is divided into four segments. One is a data segment, one is the index segment, one is a temporary segment, and one is the undo segment. So these are the four segments that is used in the database architecture. Then standard table in Oracle is keep organized, that is a storage location of a row in a table is not based on the value that is used in the table, that is contained in the table. And if the table is partitioned, the content of the row affects the partition in which it is stored. So whatever the condition or whatever the partition that is used, that will be stored in the data that will be available in the data. So the Oracle also supports the nested table that will be used. That is, a nested table means a multiple table that will be used in the database admin, that will be used with the database architecture that is available, that is used to the database blocks. And that is known as a multi-table clustering that is used. That is, a multi-table clustering is used for the database admin. Then the index organized table, that is on the basis of the index that is used, that is available with the index that is available with the database admin, that will be used, that is used for the database admin. And next is the compression, that is the Oracle also provides the compression technique, that is how to compress the data, how to make the data available, that is used with the compression technique that is used with the various transactions. That is a compression that Oracle provides a feature that is available that is stored in the compressed format, something that can drastically reduce the amount of space that is needed to store the data. Then next is the data security, that is one of the important concept that is used. So data security that is used as a database tool that will be available in the database concept. Then one of the important technique, one of the technique that is used with the database admin, that is used with the database blog, that is a admin that will be used, that is available with the database architecture, that is used via we can say the database architecture, that is the encryption. So one of the technique is the encryption, that means encrypting the data, that means changing the form from the original form to the any other form, so that it will be used, it will be available in the content, that will it will be available in the various data that will be available with the various content. Then encryption means changing the form into multiple form, that is the changing the form into multiple data. So Oracle can automatically store the table data in an encrypted format and can transparently encrypt and decrypt the data using the AES or the DES algorithm. So these are the various algorithms that will be used. That is encryption, that means automatically store the data in an encrypted form in another form that will not be understood by the any other third person. These are the various we can say the security concern that will be used. Then the function based indices, join indices, domain indices, these are the various indices. Now next is the partitioning, that support or Oracle supports various kinds of partitioning, whether it may be horizontal partitioning of table and indices, and this feature may also provides a major role in the Oracle ability to store or support various large databases that is available, and the ability to perform a table on index has advantages in many areas. So what are the various advantages that is used in the partitioning the table into various indices? First is the backup and the recovery are easier to maintain. So whenever the data is divided into multiple indices, so in this case, the backup and the recovery that is taken, that is very easier and faster technique, since they can be undone or since they can be done on the individual partition rather than the table as a whole. Then loading operation in a data warehousing environment are less intrusive. Then the query performance benefits substantially, since the optimizer can recognize that only a subset of the partition of a table that need to be accessed in order to resolve a query. Then next is the range partitioning. These are the various partitioning techniques. Then query optimization and the processing and the optimization, that is the same concept. I'm just coming within 2 minutes. But so next is the query processing and the optimization, that is what are the various query processing technique that will be used in the query optimization techniques. These are the various execution method, these are the various we can say the execution that will be used to access techniques, that is access technique, that is access methods. So data can be accessed through a variety of access method that will be used. For example, the full table scan, then the index scan, then the index fast full scan, then the index join, then the cluster and the hash cluster access that will be used. That is a clustering index that will be also available with the database access. Then optimization, that is also we have covered, that is a query optimization, that is a query transformation, that is transferring from one place to another place. Then the access path selection, then partition running or pruning, then SQL tuning advisor, then SQL plan management, that is how to plan the various parts, that is a SQL plan management, that is a then the parallel execution, then process structure, then result caching. So these are the various we can say the query optimization techniques. The next is the concurrency control and the recovery, that is the next part, that is how to control the concurrency and how to recover from the concurrency if there is any concurrent conditions, that is any fault in the concurrency conditions. First is the concurrency control, that is done with the various protocol, that is a two-phase locking protocol, commit protocol, that is also available with the concurrency, or that is also including in the concurrency control. And next is the basic structure for the recovery. That is, what is the basic structure? The structure that is used for the Oracle recover from the failure such as the disk crash, since it is very important to understand the basic concepts. Then Oracle data guard, that is also used. Next, system architecture, there are various architecture that will be used for the system scenarios. Then shared server configuration, that is in which the shared memory part will be used. Then the Oracle Access data. Then next is the replication of the data, distribution and the external data. Replication means the duplication of the data that is available in the distributed way, that is available in the existing way. Then data mining, that is how to mine the data, how to find out the data. That provides a variety of algorithms that embed the data mining process inside the database for both for building a model on the training set of data and for applying the model for scoring the actual production data. So the data mining means extracting the data from the database for building the model on the training set of the data and applying the model for scoring the actual production data. Then the next chapter is chapter number 29, that is the IBM DB2 universal data. That is not in our course. So we have finished this module, that is the database design concepts, in the today's class. From the tomorrow's class, I am going to start with the new module, that is employability and the professional development. That is the new module. So we will going to start the new module in the next class, that is in the tomorrow's class. So that's all for today's session. We have wind up this module, that is the database design concept. So congratulations everyone, we have finished the big module and the important module, that is the database design concepts. So thanks a lot everyone, bye bye. And from tomorrow onwards, I'm going to start with the new topic, new module, that is the employability and the professional development. So thanks a lot, bye bye everyone. Yes, hello Joseph, how are you? Good afternoon. Okay, welcome Joseph. Yeah. Next module is employability and the professional development. Assignment for the pardon, assignment for computer system. Okay, yeah, computer system, that is in the process. The main procedure is that I have to submit the assignment to my internal verifier. That internal verifier verifies the assignment, then submit the assignment to me. So that is a we can say the long procedure that is followed. So I prepared the computer assignment, already submitted to the internal verifier. Whenever the internal verifier submit to me, I will share with you. And next module I'm going to cover within this month only, that is the 6th module, and the remaining 10 module, that is I'm going to cover within 15 days or the 20 days, because that are the two short modules, not lengthy modules. Yes, I agree. So 9 months means 10 modules, so it takes around 20-25 days for each module. Because we have covered so many lengthy modules in this session. Now whatever the remaining module, that is a very short module, that takes around 20 days to 25 days. No, but we have already covered with the C, C++, so you are familiar with the programming concept. So there is no hard and fast rule to go into depth with the programming in the Java. Okay, bye bye Joseph.